It's important to know this factoring technique called factor by grouping. It can help you factor larger polynomials next year without using grade 12 techniques. So let's try pulling out the GCF. The GCF of these two random terms is 7a. We get 1 plus a squared. As for these two terms, we're going to group these two terms. We're going to pull out the GCF a to the 4. So we get 1 plus a squared. Notice how we have twins. We'll pull out the GCF 1 plus a squared now. 1 plus a squared. Set up some brackets, and we'll throw these terms in here. So we have 7a plus a to the 4. But remember, we're not done yet. Always factor fully. We can pull out an a here. So we have 1 plus a squared. We pull out an a. We get 7 plus a cubed. And we can always rearrange this. We can write this as a squared plus 1. We can stick this a in the front. And we can call this a cubed plus 7 because addition is commutative. So this here is the fully factored form. Now, what is the area of the shaded region? We'll call this purple. Below in fully factored form. Notice how the radius of the larger circle is x plus 2. So the entire larger circle, the area of the shaded, is the area of the large circle minus the area of the small black circle. So the area of a circle is pi r squared, and the area of a small circle is pi little r squared, the little radius. Now what is this big radius? Is x plus 2. As for the little circle, the radius is x, so instead of r, we'll use x. Now we can factor out the pi, the GCF of these two terms. So we get pi, we get x plus 2 squared minus x squared. And think of this as a. This here is a, which is x plus 2. So we know that if we have a squared minus x squared, we use difference of squares. A plus x, a minus x. So in the same way, we're going to factor this part here. So we have pi. We'll set up some big square brackets. We have a plus x, in which a is x plus 2. So we have a plus x. And we have a, which is x plus 2, minus x. What is x plus x? It's 2x plus 2. And x minus x, they disappear, and we have 2. This 2 can be promoted to the front, so we have 2 pi times 2x plus 2. But don't stop here. Always pull out the GCF, and there's a GCF of 2 within this bracket. So we have 2 pi times 2, we have x plus 1. Because when we use distribution, we realize we have 2x plus 2. Finally, 2 times 2 is 4. So we have 4 pi x plus 1 as the area of the shaded in fully factored form. Let's try another challenge problem. Let's find the possible values of a k such that we have this trinomial and a constant term plus 8 that can be factored. So let's try brute forcing this question. We'll try 2x times x, and why don't we try 1 and 8? Because when we look at the constant 8, we can break it down to 1 times 8 is 8, and 2 times 4 is 8. But notice how we have to deal with constant numbers that's either both positive or both negative, because negative times negative is positive. We can't have them being different signs. So let's try plus plus. What's the k value? We have outside, inside. 2x times 8 is 16x, plus 1x is 17x, so the k value is 17. Now what if we have 2x minus 1, x minus 8? Then we have the k value. This is minus 16, minus 1 more x is minus 17. Instead of plus, we have minus, so these come in pairs. Now we can't do this. We can't say 2x plus 1, x minus 8, Because the problem with this is that a positive number times a negative is negative, and it says here that the constant must be positive, so we'll reject that. So we're still using 1 and 8, but this time let's switch 1 and 8. Let's try 2x plus 8 and x plus 1. Now what do we get for k? We get 2x plus 8x is 10x. So k equals 10. And when we go both minus, we get minus 2x minus 8x is minus 10x. So k equals negative 10. So we have another possibility here. So we have 4 total possibilities of k when we focus on the numbers 1 and 8. Now let's focus on 2 and 4. We have 2x plus 2, and we have x plus 4. So outside we have 8x plus 2x, we get 10x, so k equals 10, which is a repetition of this answer here. And when we choose negative instead of plus, we get negative 8 minus 2, so we get negative 10x, where k is negative 10. Same answer. We're not going to repeat these answers. Now let's try switching the 2 and the 4. Let's try 2x plus 4 and x plus 2. What do we get? We get outside 4x plus 4x is 8x, so k equals 8. Now what if we go minus instead of plus? We have negative 4x minus 4x is minus 8. So we have 2 unique k values. So we have a total of 1, 2, 3, 4, 5, 6 unique k values.